This talk is about studying experimental economies with human subjects and the zero lower bound and the behavioral expectations of human subjects in the while in the liquidity trap. It's a joint work with Luba Petersen, my colleague from Fraser University. So there has been a question of how the monetary and fiscal policy should be conducted and implemented when the nominal interest rates are close to zero, and that has been a topic of debate and also discussions in the literature on monetary and fiscal policy, as well as some of the learning literature that we've seen. And what we are doing here is trying to see how these policies are going to different policies are going to affect the behavior of experimental economies with human subjects when at the zero lower bound. So what we are going to do is we are going to try out and see what happens after a huge demand shock that hits the economy, and when the zero lower bound on the nominal interest rate hits, how four different kinds of policies affect the outcomes. Do they help stabilize the economies? If they do, how fast? And if there is any difference in the success of these policies. So the ones that we are going to, am I doing? So basically, we will be looking at the sort of a constant target, constant inflation, Taylor rule with a strong monetary policy. We will be looking at the policy that implements history-dependent inflation target with two variants, and then a policy with a fiscal stimulus that comes from the inspiration comes from the work of Evans, Goose, and Honkapohja, then Beib, Evans, and Honkapohja as well. We will also look at how effective the communication is of the central bank in these times of basically recessions or even deep recessions, whether the communication helps these economies overcome liquidity traps and coordinate expectations on more optimistic outcomes. So we want to see how policy is, if it is able to influence these expectations, and our history-dependent target treatment, which is inspired by the work of Egerton and Woodford, we want to see how the quantitative communication of a target, where the subjects are told the exact number that the central bank is targeted, fares versus what we would call a qualitative communication, where the central banks communicates whether they're going to increase or decrease inflation rate compared to the previous period. Finally, we want to see how the monetary policy with a constant target inflation rate combines with the fiscal stimulus affects the outcomes, and whether it helps alleviate liquidity traps. So recent work in the literature that looks at the basically surveys or forecasts, both of the households and firms, and as well as professional forecasts, show that these also of interest, especially the recent work, for example, of Andrade and Lebihan, who show that professional forecasts do not always update their forecasts, and when they do, they still make systematic errors. In addition, they don't update to the same forecast. So there is evidence out there from this survey data and empirical work studying those that expectations even of those professional forecasters are do not take. Do not basically use all the available information, and do continue making systematic errors. So, what is the advantage of doing experiments versus doing this work on surveys? It is there are following, and we know them all. General advantages of doing experiments in the laboratory, controlled experiments in the laboratory, which is that we know exactly what the data generating process is. We know what kind of information is given to the subject. We can create a lot of different independent observations. We are not just stuck with the data set that we have out there. And we can allow to study different kinds of policies and environments, as well as we can, because our human subjects will be making forecasts, we can properly incentivize those. In other words, they can be paid in an appropriate way for being accurate in their forecasts. So just a quick, there has been work recently done in this area of where the researchers have studied how these economies behave in the environments where human subjects have to make production and consumption decisions, and then there is also a large number of papers that are studying the behavior of these economies in the so-called learning to forecast environments, where subjects make forecast expectations. There's some surveys done recently that basically, which are good references, which provide a good overview of this literature. Now, one thing to say here, and that paper is referenced, I will come back to it later just for a brief comparison with ours. Besides ours, there's a paper by Hames et al. Who studied also the liquidity traps in these kinds of situations in a different in a nonlinear type of a new Keynesian model. And again, when I describe our environment, I'll briefly refer back to point out the differences and similarities between the two approaches. So these are the questions we'll study. How the history-dependent inflation targets, can they reduce the length of the expectations-driven liquidity traps? Are qualitative rather than quantitative communications of inflation targets more effective at coordinating expectations? And then will the anticipated fiscal stimulus combined with the aggressive monetary policy alleviate liquidity traps? So maybe I can go this side. More easily. So we had sessions that consisted of groups of 9 subjects playing the role of professional forecasters, and each subject in this experiment submitted 2 forecasts: the forecasts of the next period's inflation, as well as of the output gap, which we refer to as just output for simplicity. And forecasts are submitted in basis points. They could be negative and positive integer. There was no limit to what these forecasts could be. We used median forecast in calculation of realized output and realized inflation rate. This is our scoring rule here that we use to calculate the points that human subjects would obtain for their forecasting. Of course, it depends on how accurate these are. Basically, the bottom line for this rule is that it monotonically decreases the amount that's paid to the subjects with the increases in forecasting error. Every 100 points decrease in the forecasting accuracy leads to the 50% decrease in the number of points per period. The maximum they can earn per period is 0.6, and the minimum is 0. Okay, so our data generating process consists of investment savings, a curve, and then this is how basically how the inflation evolves over time, and this is where our median expectation of the next period's inflation will come into play. And now for the nominal interest rate, we have these two. Basically, if the nominal interest rate is greater than 0, then this is the rule that governs the determination of the nominal interest rate. Otherwise, if according to the calculation this would have been less than 0, then it's truncated and just set equal to 0. We have a shock process for the natural interest rate, which is so it's a AR1 process with some noise. And this is basically taken from some of the empirical evidence and recent empirical work done where this estimate for the AR1 coefficient was used. Now, in addition to this, so this is something that governs the shock process all the time. In addition to this, we do impose a huge shock of minus 400 basis points at a given point in time, and this is an impact of the crisis. Subjects do not know when exactly this will hit the economy, but they see it at the moment when that happens. The steady state levels with flexible prices for this model are X star, the output gap, equals pi star equals 0, with I star equals to our natural rate of interest at that point, which is 75 basis points for our calibration. So, our inflation targets are a constant inflation target, which is just a classical Taylor rule with the pi star t equals to 0. And then in the history-dependent inflation target, this is basically how we compute the inflation target for every period. This calculation obviously takes into account the parameters of the model of the environment itself, beta, alpha, kappa, beta again, risk coefficient of risk aversion, past values of output gap, past value of inflation. And the way we calculated it, we took the Agerson and Woodford's price target rule and just converted it into and computed it into to see how it looks like when we target inflation instead of the price level. So this is how history, now we also had a directional history-dependent target, positive or negative, and basically in this case it evolves the same way as with a history-dependent target, except, as I mentioned before, we don't tell the subject the exact number, the exact pi star t that the central bank aims at, but we just say it's going to go up or down. And we'll see how that impacts the And finally, we have the fiscal policy treatment, where we introduced an exogenous announced government spending. So basically, there is a GT here, which will hit the economy in the second period after the big crisis shock, and then in every period after that, as long as RNT is less than 0. Now notice when we have the big shock of minus 400 basis points because of the AR1 process, the RNT will remain negative most probably for a few more periods, and I will show you how we choose these basically lengths of these shocks, and we control for them to see how the economies react to the shocks of different length. Okay. So each one of our sessions consisted of 2 repetitions of 40 periods each. And so the first, what we call a repetition, lasts 40 periods, and we then have the second. Is it me doing something? Or?
It seems to be the door.
Okay.
I'll try to see what I can
I know, it doesn't bother me. I just want to make sure it's not me. And then so basically, once the 40 periods is over, we restart the economy with the same subject. So we sort of want to see how they, when we expose the economy to similar kinds of shocks, whether the now experienced subjects will react differently. Yeah?
What did the subjects know? What did the information say? Do they know these informations?
Yeah, I think it's, yeah, I'm coming to this. And so what we did, we ran 6 sessions of each treatment. So the total of 24 sessions, and for each for each session in each treatment, we chose shock sequences ex ante, which we will implement. Why we did this? We did this, of course, by randomly generating a number of sequences, and we were using social evolutionary learning which we took a model that is a joint paper with Jim Board and Olena Kostashina. We were simulating that model to see, it's with the artificial agents, to see how these agents react to shocks of various lengths. And so we took that as a guidance. We didn't use it as an exact description of the experimental economies, but it actually proved to be a good a good thing to guide us as to what kinds of shocks would be interesting. Again, they're all randomly generated. We just pre-selected those that looked like something where we could control the length of the shock for. So,
could you just repeat that last sentence?
Yeah.
So
The part that threw me was randomly generated but pre-selected.
Okay, I know it. Okay, so we generated using this SCL model 100 different sequences of behavior of these SCL agents with randomly generated sequences of shocks. And then out of those, we chose those with specific lengths of a negative shock during which R and T is negative, so that we had different lengths. So one we had length of 3, the other one we had length of 5, and then the third one length of 8. Do you add that? And this was just
And then you fed those into your
experimental economies, yes. And we wanted to have the same, in order not to lose control over this, we had the same sequence for implemented in session 1 of each treatment, and then the same sequence implemented in session 2, and so on. So we had 6 different sequences of these shocks with different lengths. All right, so in the first repetition, the this big shock took place around 20, and in the second repetition around 15, and it was around minus 400 points with plus minus 2, not to have subjects think it's going to be the same, exactly the same magnitude, although the difference is not that big. So, so basically, selected sequences had a relatively steady upward trend back to the steady history, and this is what we varied fundamentals recovery, which I just talked about. So what did they see? What kind of information did subjects have? I don't know how clear, we have to make these graphs clear, but basically there were 3 screens. So what they would see in each period were the realizations of the output and the inflation rate from the past period, because the current period's inflation and output are going to be determined based on their expectations for the T+1 output and inflation. They also saw the current value of the shock, and also they saw the nominal inflation rates. They also saw everything, all the history up to that point of their own forecasts, as well as on the of the actual realizations. They could also see or mouse over to see the difference in terms of forecasting accuracy between the realizations and what they were forecasting. So they could see all of the past history and everything until that point.
How much do they know about the structure?
Mm-hmm. So let me see if I have that. Okay. I just want to see if I have any. Okay. So what they know about the structure is we provide them with the first with the qualitative description. So we would qualitatively describe the relationships between how their forecasts feed into the determination of output gap and inflation, and what are the general goals and objectives of the central bank for different treatments. Again, qualitatively, instructions are available. I don't know if they're in the paper, but they're online. And then we also provided them the technical, basically we gave them the equations. So we did go through those equations with them as well, and they could use them if they wanted. So we tried to compromise there between different kinds of sort of approaches in experimental economics, where some argue that subjects should not see exact equations because they might not understand them. some others which might include a little bit myself in that category, is that it's easier if they can understand a few numbers to actually show those equations which are not too hard, rather than go on and on trying qualitatively to. But anyhow, that's what they had, both qualitative description and quantitative equations. So this is our Center for Research in Adaptive Behavior in Economics. And we do have 2 labs now at Simon Fraser University where we are running our experiments. We have a lot of people now doing those. And so the pool is from Simon Fraser University. Our sessions lasted for 2 hours, and instructions took quite a bit of time because we wanted to make sure that these guys understand these fairly, complicated economies. We did have quizzes and test questions. We made sure that they answered correctly and tried to make sure that they really did, after these instructions, understand what was going on. They had 5 periods of practice. This didn't count towards anything. During this time, they could ask questions, and we would yeah.
So what are the backgrounds with the undergrads, graduate students?
Pardon? What is what?
What are the educational backgrounds?
They're undergraduates.
They're undergraduates from Simon Fraser University.
Particular field or just random?
Pardon? Can you speak?
Particular field or random?
Oh, okay. So we have as any experimental lab, we have a database of students who sign up to participate in these experiments. And then there is a recruiting software that we use to send announcements when a particular experiment is conducted, and they can sign up. Now, these guys each participant had not participated in any of these sessions of this whole experiment before. So they are, sometimes you might want to look at the behavior of those who had already taken part in similar things, but here we filtered out and made sure that these are new subjects. Okay, so our show-up fee just for showing up to these is $7. Well, if you calculate it, I don't think anybody ever got 52, but this would be making perfect forecast all the time. And then this is basically what they were earning, from $20 to $33, 26 on average. And so we had 6 sessions of each one of these treatments, total of 24 sessions. So our observations are that of course, these expectations-driven liquidity traps do occur. What we mean by this, you will see in the pictures. There is a shock, but then expectations do not recover. They go downward. They follow a downward spiral. In addition, they kind of become worse and worse sometimes, quite heterogeneous. And overall, it's not easy at all to try to anchor them and coordinate those expectations towards better outcomes. Bruce, I don't have a time. I thought I would.
You have 15 minutes,
Okay.
and I'll tell you when you have 10.
Okay. Sounds good. We also, the finding is that creating inflationary expectations via this history-dependent inflation targeting does not work well, and that the speed at which fundamentals recover plays an important role in aggregate stability and recovery. The fourth thing is that constant inflation target and fiscal policy, these are highly successful at taking these economies out of liquidity traps. We should work on these graphs. So what you want to see from here is basically this constant target, that's repetition, 4 different treatments. This is second.
If you go back to the previous slide, just
Sure.
1 second.
So this is, I guess, the fundamental recovery, FR3. So it takes 3 periods before the RNT becomes positive. But you will see, I don't know how obvious in these pictures is, which we squeezed too many of them on one slide. We have to do something about this, but even though the fundamentals can recover, the economies will still stay in the liquidity traps because the expectations do not recover, and they just further, continue going down, and in many of those, and being pessimistic. So
this is under what policy though? Because you're first in.
yeah, this is constant target, just a Taylor rule. And so, what is happening here? The petition one, remember, is the first 40 periods. And so this is split, again, we have to find a better way of representing this, but this is split into the sort of a pre-shock phase where they're kind of, if you can see, this is between 400 and minus 200. So there is some, fluctuations there as well. It's not like they're just all the time very close to the steady state, because there are some shocks to the RNT as well.
What
right?
variables are these? Is this interest rates or what is it?
Yeah,
Oh, I
to
see.
walk
Okay.
us.
Oh, it's
So-
all together.
It's all together, yeah. So you can, the blue is output, sort of a green inflation, yellow interest rate, red shock, blue inflation target, and sort of a lemon green or lime green government spending. And now one thing to watch here is that now we have a little bit of change of the scale. This is where the shock hits. And so that it's not so, it might look stable, but because of a different scale, it is not really that stable. So I have to figure out how to sort of make these comparable. History dependent. So you can see here they're kind of not very stable even prior to the shock. Now the shock hits, but here we have again a different, a completely different, a different scale as well. And they're basically, there are long periods. We don't see stabilization here in the end. This is a directional state-dependent target, and then finally we have a constant target with fiscal policy implemented in it. This is where the shock takes place, but then we have a government policies. But oops. All right, I'll just go a little bit faster.
So there's a gap. So when you say, just because I'm a little behind,
Yeah.
when you say inflation target, so then that implies a certain set of rules that the monetary authority is using. Is that?
Yes. Yeah, the one that I showed at the beginning. Yeah, so it's inflation target 0. Like 0 is just a standard Taylor rule with a fairly high coefficient on the inflation rate. And
Okay, that's what that means.
yes. Yeah.
Can you just remind me, what is the difference between the, how do you read the two graphs differently on the right-hand side panel, the first two graphs? Just to get an idea.
This is pre-shock. I mean, this should be really, these two should be together. Okay.
Yeah. My question is, on the right-hand side, the top two graphs,
Mhm.
they are for different policy rules, right?
Yeah.
What is the what are the stylized differences between those two pictures? Because of the scale, I can't figure it out. So,
Right.
is it that one is more?
Yeah. No, I see what you mean. So in this particular case, because the shock is fairly short, but so we are talking here of minus 10,000, while here we have not more than minus 400. Let me okay. It's not even easy for me to show. Okay, I don't have enough time to go into. I will show you the differences between treatments in different plots. Okay, let me just. These don't seem to me to be very useful, but I mean, like sort of here, when the length of the shock is 8. Okay, you can see here. So when the length of the shock is 8, you can see here that prior to the shock, right? They're kind of fluctuating because of the shocks. But then when the shock hits here, now here we are, I can't even see, but this is like e to the power of something. So this might look straight, but it's not straight at all. It's going all the way down because of this part here, which is just going towards the minus infinity. So, and then in this one here, there is a little bit more of stabilization, but again, the numbers here are really very, very negative. It's just in absolute terms are quite high. The same is here as well, because so here is the e to the power of minus 7 or constant target. This goes between 400 and minus 400. Okay, so it's stable.
So exactly
Yeah.
how did you get those pictures? You took the responses and you fed them in the structural models, and then you traced out the path for endogenous variables. Is that how you got those pictures?
Yes.
So they said something which made the endogenous variable go to e to the minus.
Yeah.
What did they exactly say that time?
We were thinking about it. It's a drawback. I don't know how to, because it's if you impose some sort of a artificial bound on how far they can go, you wouldn't see. It would bring a different distortion to this. So we didn't know a good way of dealing with this. I would welcome some, because whatever you do, I mean, this is what happens in the learning model literature as well. I would say if there is instability, it just goes, it goes to infinity. I would say, if there's
But I mean, what is it? It's just a big crisis or a big liquidity trap, and you could just cut it off. I mean, that's the only interpretation, and that the experimental economy ends up in a big crisis.
Sure.
But we can't see what happens in the first 20 periods.
Because of this. So your suggestion is just to cut off where and
Yeah,
make
I mean,
it. Yes,
so
that's good. Yes,
The
thanks.
interpretation would be, well, in the experiment you had a severe crisis, and then at least
You
at the
show
end,
this part
at
where,
the
yeah.
end,
Yeah.
So I've lost track slightly. See, the fundamental recovery thing, that takes 8 periods to recover. But at the beginning of that, there's a huge shock.
Yes.
So do agents in the rational expectations model know the stochastic properties of that shock?
Yes.
Okay.
Oh, yes.
The big one.
Yes.
Okay.
So are there any sort of discernible differences prior of these different policy regimes that you look up prior to the shock?
So that's a good question. No, we were looking at this, and we were looking. So in all of these, there is quite a bit of heterogeneity in expectations. And the one thing that we actually noticed is that there is more heterogeneity in the history-dependent target, but it's not statistically significant compared to the others. Now, why this might be the case is because if you have this one number, right, that they are supposed to coordinate on, and you see that this is not fulfilled, that the actual inflation is getting further away from this number, then they lose any kind of anchor, and and they start trend chasing, or but with different speed or different coefficients, and so it's very hard to anchor them back to something where the economy might improve. There's less of that in the constant target, as well as in a directional. In the directional, in fact, they do get a bit more coordinated. So there's less heterogeneity, because our interpretation is that it's easier to get just sort of, even if they just all move upwards, if it says the target is going to up, it's going in the right direction, right? Even if they just move in the right direction, that's better than looking at this number and saying this is, total loss of credibility. So, I mean, among other things what this speaks to is that, and of course, if you think about history-dependent inflation targeting, it's optimal monetary policy with commitment and rational agents. But rational agents who are going to who believe, I mean, there is implicitly there a built-in notion of credibility, right? And we don't question that in that kind of a model, but credibility is a huge issue here, right? So there's no a priori reason to believe that these policies are going to be credible. And it is crucial. It's been also discussed in the literature, of course, that if you don't have rational credibility and rational agents, then it's not clear what the central banks should do. And if you look at the evidence, some of the central banks, particularly also the Fed as well, in the past have been kind of reluctant on, not all of them, some did. There's some evidence of central banks saying what the exact inflation target is, and some saying, well, being more vague about it. And this is, you can see here some underlying reasons why this is, even though it's a lab, why it might be tricky to say, oh, I'm going to target this particular number. Okay.
Jasmina, I mean, a fundamental difference between the first two panels, for example, is having a history-dependent target in a non-rational world means that the central bank itself will reinforce past errors. So it misses its target. It's now going to make decisions that depend on the outcomes of the mistargeting.
Exactly.
Period. Whereas the inflation target, I'm trying to nail zero period by period. I just go, okay, I missed it last period, now I'm going to revisit it. And that raises the question about you've interpreted a price level target as being an inflation target that's history dependent. Those two policies, while they in general they're equivalent under rational expectations, they're fundamentally different under non-rational expectations. So I think it'd be interesting to look at a policy specified in terms of the price level because it may have better stabilization properties.
That's an excellent point. I was actually going to bring that up because we talked about this already. I looked at that work and I know this work. If it's an inflation targeting policy, under adaptive learning, it's not stable. Well, it can be stable under price. So this is exactly one of the things that we want to do next.
Can you say there are no big differences prior to the shock between all these policy regimes?
Okay. In what terms do you mean?
In terms of volatility of inflation or output gap?
No, I can show you
Correlation.
no, there is. No, let's just skip the, okay, so this was just to show you the length, how it depends on the length of the shock. 0 is stable, 1 is unstable, just quickly, so you can see some stable ones here, and then fiscal policy, all but 1 is, they're all getting out of the liquidity trap, where there is a particular definition of what it is. Let me get to some. Okay, so this is a relative length trap as long before the nominal interest rates become positive. So this is the length of a trap. I want to get to some data that shows okay, standard deviations of inflation. So I see this is something, I'm not sure if it's in the paper. I'm pretty sure we did this. I don't know if I have a graph here. So this is showing standard deviation of inflation, but this is over the entire repetition. So it's not segregating I know we were looking at this, whether it's currently in the paper or not, I'm not sure. The only thing, okay, so this is another thing I have to go back and see. But I do know that there is a difference in heterogeneity, yes?
These numbers have some economic interpretation. What is 1E27?
Well, we're going to remove this from following car system.
I mean, are you taking these graphs or this analysis as some recommendation to a policymaker? Certain types of rules have certain types of properties?
Okay, sure. I mean, so what's the for policymakers? First of all, I mean, what is happening in these economies and these huge numbers, these are the properties of these economies if they are unstable, right? So even if you looked at the theoretically learning model or adaptive, if it's unstable, it's going to go whatever, it takes it. So this is not something for the experimental economies per se. And secondly, it does have, in fact, here we can see, because this is a standard deviation of inflation. So what we can see here, and then again, I'm not sure if this is because of the liquidity trap or for clause, or because of the previous. So there's constant. You see that direct history dependent has much higher. Here we are going into ease, right? And then directional is sort of there's a huge spread of different standard deviations. This is fiscal, so it has the smallest. By far the smallest. So what you can see from this is that the constant target with the fiscal stimulus is getting towards stabilizing these economies. Okay, so just a question.
I mean, the reason I've been asking for different performance prior to the shock is if there were a lot of very different behavior of inflation before the shock, and therefore different beliefs maybe of agents.
Sure.
Then you're not comparing similar experiments.
No,
Because
absolutely.
then you're having maybe inflation, that negative shock hit at the point where inflation is already very low, while in another
Yeah.
environment, you wouldn't have that.
So again, I have to look back. I know we've done the analysis because I was interested in looking at this. One thing that we have is again, that's why we wanted the same sequences, at least of fundamental shocks to control for that. I know that there's more heterogeneity, which would, so if I have a same fundamental shock, right, if I have more heterogeneity, then it might be imply more volatility a priori. And I was thinking, and I think that history-dependent target has that. But again, the problem of it is that it's this kind of a rule that's built in. But I will definitely take a look at that and have those analyses more clearly spelled. That's an excellent suggestion. Just the last point, it goes back to what Evans and Goose and Konkapoya and Ben Habib as well had in their paper, right, showing how this fiscal switch can improve things. And this is what Carr's paper with Isabella and Domenico shows as well. They use a different nonlinear version, which is that's better, but they look at the shocks to the expectations, and they compare basically what I call a constant target tailored rule policy versus combination of that and a fiscal stimulus. Okay, thank you.